Hey there, viewers, and welcome back to the South Main Auto Channel. Sitting inside the 2003 Subaru. It's a Forester. It's got the big 2.5 single red cam, naturally aspirated engine with an automatic. The guy told me that he's had some issues with this car. One of them being that the engine light comes on, and I see he left a receipt here from the year 2019. So several years ago. It appears at 61,000. It's got 93,000 on it, so 30,000 miles ago the car had a head job. Probably irrelevant to whatever he's having happening today. So we're not even going to bother with that. Just something to keep in mind. That's some work it's had done. But what Subaru hasn't had a head job done on it? If it hasn't, it's going to have. Engine lights on. I've got the all-tell here. We're going to hook it up. We're going to read the codes out of it and then see if it has anything to do with that, which I doubt it does. So we have a P0032 pending and current, or old and current as Subaru puts it, and it is for a heater control circuit high bank 1 sensor 1. So not a big deal. Now the guy did mention though that he was driving it after an extended drive on the highway. He got off the highway, went to accelerate again, his engine light came on and started blinking. And then it quit blinking, and then the light went out, and that was kind of a one-off isolated case and hasn't happened since. And I see that we have no misfire code in it, so that's good. I don't recall talking to him how long ago that was, but he did tell me, he was just trying to tell me everything that he could think of. Perhaps after an extended drive on the highway, maybe his EGR stuck a little bit when he got off and did that, but all the monitors are complete. There is only one code. We're just in generic OBD2 right now, which is always my habit, especially on Subarus. So we're going to see, make sure, pending and current code P0032. So that's it. That's all the direction we have. We'll take it for a little rip around town. We'll come in, see if we can figure out what's going on with the heater circuit. Probably just a failed air-fuel ratio sensor, but in either case, it's a video for us, and we got to start somewheres on this, so good as place as any. So I'll show you some scan data. I just popped up here so we can see the current draw from the air fuel ratio sensor, or oxygen sensor, whatever it has in the front. I think it's an AFR on this, and then the rear oxygen sensor. You can see it's drawing 1.1 or 1.06 amps, and not drawing any current on the front. Find us a seatbelt. Oddly enough, the cruise control light is not flashing, and I don't know why. Typically on a Subaru, when you get an engine light, you also get the cruise light. Well, a short little test drive there. Everything seems to run and drive normal as it should. Let's go back, have a look at this O2 heater. See if it indeed is a circuit problem or just a simple failed O2 sensor or AFR sensor. So let's see here, folks. I removed this little guy from the air cleaner so we can get down here. Both O2 sensor connectors are down passenger side of the engine. There's one running to the back of the converter, and then there's another one right directly here that runs to the front of the converter. We're just going to get ourselves a little bit of room. We just want to check the O2 heater itself in this sensor. Now I've seen where the wires come down through. Now these are real notorious for wrapping the wires up in the front CV axle. These ones were actually right tight to it, so I thought for sure they're going to be rubbed through, but indeed they weren't, which is good, I guess. In that sense, let's see if we can't get it unplugged here. These things can be a piss pot to unplug sometimes. That one wasn't too bad. So there's that. Let me see. I don't know if you guys can see the connector. Yeah, you should be able to, I think. And then it's going to be the two wires that are similar in color. So we got a white, a blue, and a couple of blacks. And then we're going to get our meter and go, there we go. We're going to put it on ohmage. I don't know what the resistance value is specifically, but it's going to be probably 20 ohms or less would be my guess, if it was good. This one is probably going to be 0, or open rather, not 0. 0 would be bad. Find a spot to put this where everybody can see. Make sure our meter works. I don't know if you guys will be able to see the meter or not, but make sure our leads are good. They are. They're at 0. I'll let it auto range. Grab this, the 2 black wires. We'll probe that one there. Probe that one there. Survey says, let it settle out. 14.69. 14.69 it says. Mega ohms. This is a good lesson here for you folks, to make sure that if your meter is in auto ranging mode, that you look at your values, because as I just mentioned, it should be, you know, I assume around 20 ohms or less, more than likely, let's say 14 ohms. That'll put us about an amp. Let me put this where you guys can frickin' see it here. Okay, there, you guys can see it there. I'm gonna take and probe the 2 black wires again, and we'll watch the meter move around. And let me get to where I can hold that steadier here, folks. Stand by, stand by. Let's see. Get to where I can hold that one steady. I should probably use one of my front probes. So we're holding that. Of course, it's going to be kind of all over the place. But if you look at it at a quick glance, you're like, oh, you know, I got 20 ohms, 21 ohms, 24. But see the M on the right side of the screen is mega ohm. So that's super high ohmage. All right, we were hoping for something way less than that. So that's it. I mean, to start with, we need a new sensor. You can see now when we look at scan data, we have front O2 heater, rear O2 heater current, and our front is now at 0.2 amps, and our rear is still where it should be. Well, why is that, Eric? Well, we installed a 1/4 amp test light. So straight across the 2 black wires, let's see, right in the back probe, right in the connector, and you can see our lights down there flickering away. It's probably, you know, duty cycle controlled, but it's drawing 0.2 amps. And our test light is 0.25 amps. It's a 1/4 amp test light. However, it's not keeping it on steady. And you can see we yank it out. We're down to 0. So what's that tell us? It tells us that our circuit is intact and that the PCM has 100% control of it. That it has a good power supply, a good ground supply. I don't know which comes from whether it's fed a full-time power and the PCM supplies the ground, or if it has a full-time ground and the PCM, you know, duty cycles the power. But really in this case, that's neither here nor there, and it's not important because it does work. We install a 1/4 amp load. We see almost a 1/4 amp load on the scan tool, and then, you know, we know that the PCM can turn it on, and obviously it can detect that circuit, it can detect an open in it, which it has, and it's nothing more than just a failed O2 sensor, and we confidently tell our customer that. We need an O2. Circuit's good. We can put it in, clear the codes, and adios. That's going to have to do it for this one, folks. Cannot get a hold of this customer. We're going to have to wait for him to call back to get permission to replace it. Got him an estimate around. Part is available for today. It is an air-fuel ratio sensor, a little on the spendy side, but I think we've done enough to prove to you that the O2 sensor has failed. The car has control. It can obviously control it from what we've seen. And the rest of it's just, you know, unscrew it, screw the new one in, clear the codes, and adios, muchachos. Send this baby packing. Why don't I send you packing down to that comment section? The questions, the comments, the concerns. Look for us on the socials, the Facebook, the Insta. And just remember, viewers, if I can do it, you can do it. Thanks for watching.